globe, science and technology are evolving at a rapid rate. The Medical College of Wisconsin maintains this pace with its culture of innovation. Founded in 1893, the Medical College of Wisconsin is a leading medical school, research center, and clinical care provider. Let's sit down with a scientist who's been internationally recognized for his research, Dr. Kalyana. You received your master's degree in chemistry from the Indian Institute of Technology in Bombay, India, and your PhD in chemistry from the University of Alabama. Tell us about that transition.
After I got my master's in chemistry, I wanted to do research, but I did not know exactly what type of research I was going to do. And then I decided, well, I'll work first in an industry, and a job became available, and I started working there. And after I started working, and after a year, I found out that the work that I was doing was very routine, and I was not enjoying that, and it was not inspirational. So I decided to do something more innovative and something more inspirational. And also, my brother and my cousin, they were doing research in the United States, and they got their PhD, so I decided to follow their footsteps.
Excellent. What are some of your current areas of research?
Currently I'm working in cancer-related projects, and I'll tell you how I started working in cancer.
You said neurotoxicity?
Yeah, initially I was working in neurodegeneration, that is the death of neurons. Many diseases are characterized by the death of neurons, and one of them is Parkinson's disease. And when I was working in that area, we discovered many drugs that will stop the inflammation in the disease. And it became clear that cancer is also an inflammatory disease. So we decided to start applying the drugs that we developed for Parkinson's disease to cancer research. And even though that was completely a different approach, and it turned out to be a unique approach, because some of the drugs that inhibited the progression of Parkinson-like symptoms also inhibited the cancer cell proliferation. And one major difference between cancer cells and normal cells is that cancer cells proliferate much faster than normal cells. So you need to get some drugs that selectively inhibits cancer cells, and some of the drugs that we developed did exactly what the cancer biologists wanted to see. And so that became somewhat of a new and novel treatment for at least from a cellular point of view to stop proliferating cancer cells. And now we are working on taking those drugs into the clinic.
Excellent. What are some of the problems that research scientists find when looking at cancer cells?
Initially, there are some successes, but then immediately they find out that cancer cells are very smart. And once they find a door is closed, they'll start opening many doors for them to proliferate. So as a result, scientists have to be constantly on guard, and that's one of the reasons cancer treatment takes many drugs to treat, because there are many pathways by which the cancer cell can survive, and that's not easy, because it constantly keeps on changing. And even if you think you have found a drug, and very soon the cancer cells become resistant to the drug, and as a result it doesn't work. So you need to start giving a multifaceted type of a therapeutic approach to treat cancer.
How has research science changed over the course of your career?
Research science has become very complex now, and the reason for it is there are many molecular biology and signal transduction processes that have come into play. And also the more you discover about a particular disease, at least in cancer, you find out that there are many unanswered questions. So as a result, you need to find many different ways to do research. For example, a biologist should work in combination with chemists and physicists and even mathematicians in order to understand more. So because of all of these things, the science has become complex, and it's more interesting, but it has become very complex. So you need to understand science in a more interdisciplinary fashion than ever before.
Has your wealth of experience with science given you any philosophical conclusions?
It has given me one philosophical conclusion, that is, never give up. And you have to constantly keep working on it, and it is just like anything else in life. It is the process is one of it's a marathon. It's not a sprint. So you need to take everything in small steps, and sometimes you become successful, and then sometimes you think that you have discovered something, but then after you perform many other experiments, you find out that your initial interpretations or hypothesis is not correct. So then you start modifying it and keep working on it. So the philosophical approach is you just never give up, and keep working on it, and keep believing in what you are doing, and also don't be afraid to start changing your ideas, because if you get stuck with one idea all the time and think that is going to solve, it probably is. It's not correct. It's always a constantly changing process, and you shouldn't be afraid to change your ideas, and depending upon how the science evolves.
Words from an expert.